Interstellar is one of the most scientifically accurate sci-fi movies ever made. But let's be honest, it still bends the rules of physics for the sake of an epic story. Today we're exposing three of the biggest scientific lies in Interstellar that you probably didn't notice. Some of them are small stretches of the truth, while others, they're complete Hollywood magic. Let's dive in. Lie number 1, the massive waves on Miller's planet. Remember that terrifying scene where Cooper and Brand land on Miller's planet, only to realize the mountains in the distance are actually gigantic waves? Visually stunning. Scientifically, not so much. Yes, the idea of extreme tidal forces caused by a nearby supermassive black hole, Gargantua, is real. But here's the problem. Waves don't behave like that. Reality check. On Earth, tides are caused by the moon's gravity pulling on our oceans. If Gargantua were influencing Miller's planet in the same way, the water wouldn't rise into a single massive wave. Instead, it would behave more like a huge steady flood, covering everything permanently rather than forming isolated waves. Analogy. Imagine a bathtub. If you tilt it slightly, the water flows evenly rather than forming one giant wave that moves across the surface. That's what would really happen on Miller's planet. Verdict. Hollywood needed dramatic tension, so they turned water physics into a horror movie. It's cool, but wrong. Lie number 2. Surviving a black hole. Cooper ejecting from his spacecraft and falling into Gargantua's black hole is one of the wildest moments in Interstellar. But let's talk about what would actually happen if you tried that. Reality check. If you fell into a black hole, you'd experience something called spaghettification. And no, that's not a joke. The gravity pulling on your feet would be millions of times stronger than the gravity pulling on your head. The result? You'd be stretched into a long, thin strand of atoms. Basically, you'd be turned into cosmic spaghetti long before reaching the center. Imagine holding a rubber band at both ends and pulling it apart. The center stretches and eventually snaps. That's exactly what would happen to your body in a black hole, except way worse. The movie skips over this entirely and lets Cooper have a peaceful, mystical journey instead of, well, dying instantly. Lie 3. Miller's planet is so close to Gargantua that 1 hour there equals 7 years on Earth. Sounds crazy, right? But here's the twist, it's almost true, just exaggerated. Time dilation is real. When you get close to a massive gravitational object, time slows down relative to an observer further away. However, for the 1 hour equals 7 years effect to work, Miller's planet would have to be insanely close to the event horizon. At that distance, the planet would be pulled apart by the black hole's gravity. It simply couldn't exist in a stable orbit that close to Gargantua. Think of a merry-go-round. The faster you spin, the harder it is to hold on. If you spin too fast, you're flung off. Miller's planet is spinning so close to Gargantua that it should be ripped apart, but somehow, it's fine. The time dilation effect is real, but not that extreme without consequences. Even though Interstellar takes some creative liberties, it's still one of the best sci-fi films ever made. And honestly, we love it for that. Could the waves on Miller's planet happen? No. Could you survive a black hole? Definitely not. Could time dilation be that extreme? Unlikely. But here's the thing. Movies are meant to entertain. And if bending physics gives us an epic story like Interstellar, we're okay with that. Which of these scientific lies surprised you the most? Let us know in the comments. And if you love space and science, don't forget to subscribe for more mind-blowing cosmic facts.